Welcome back to TDO. Name is TT, and today we're gonna be simplifying an isometric drawing. Now a question comes and say, Figure 4 shows two views of a workpiece in first angle orthographic projection. First angle orthographic projection being our first keyword there. Do not draw all given views, but draw to scale 1:1. Second keyword 1:1, which is the scale. An isometric view of the workpiece. Point P must be the lowest point. No hidden detail required. Well, there's our diagram sheet 4 with our two views. And remember, I said the views are in first angle orthographic projection. And we only have two views there, which simply means the view that is at the bottom is what is a top view because it's in first angle. The top is at the bottom and then the front is at the top. So there's no side view given here. And by that, it means in order for you to come up with an isometric drawing of this structure, they do not need to show you a side view. What they've shown you here, it's enough. And there is our point P, and there was an instruction that was saying our point P must be the lowest point of the drawing. Alright, then let's go on and create an isometric drawing given these two views. The first thing that you do when you are required to create an isometric drawing is you produce a cube, and the dimensions of that cube, you get them from what? From the given views, from the question. The first thing that you do, you create two lines that are angled at 30 degrees to the horizontal. The first line going this direction and the second line going that direction. The next step, you get the dimensions of the lines. This point right here where your lines meet is the lowest point, given that it's point P. So you go back to your question, you check the dimensions. So if you come back to the question, you take a good look at your views here. We have a front up there at the top, and at the bottom you have a top view. The length of the front view is not given on the front view. But if you pay attention to the top view right there, since these two views represent a single component, which means they are sharing dimensions, they are equal, which means from point P up to the end, it's 85 millimeters. Given that the scale is 1:1, you're gonna use 85 millimeters because they've given you the 85 millimeters on the top view, and then the total height of the component. Since this is the top view, you cannot be able to analyze the height from the top view because you are looking at it from the top. You cannot see how tall the thing is. But if you take a good look at the front view right there, you can be able to get the total height of the component. So the total height of the component, we have this first part here up to that corner given as 50 millimeters, and then the second part is also 50 millimeters. So that means the total height is what is 100. And then the length of the drawing from the side, it's 86, which means this side is 86 long, 86 long, and also this side is 86 long without subtracting the 20. So since you know that the whole side is 86 long, and then on this side you have a 20 millimeters chamfered there, which means 86 minus 20 millimeters, you are left with what? With that dimension right there, with the missing dimension. That's why they didn't give you that dimension, because they want you to calculate. Now, when you analyze your drawing, you start by focusing on the top view. Looking at the top view, it's easier to see and to simplify many things. Now, if you look at the top view of the component, this is the top view of the component. Now, where is the left side of the component? The left side of the component is this one right here. This is the left side of the component. This is the left hand side of the component. Obviously, the opposite side is going to be the right hand side. This one is going to be the front side of the component. It's the front side of the component. And then that one is going to be the back side of the component. This one is going to be your right hand side of the component. The view that is on the top, it's a front view. So it actually shows you what you're going to see when you're standing from these arrows right here, because this is the top side whereby you can easily refer all the views from. So if you look at this top side from these arrows right here, from the front side, this is what you're going to see right there. And then The back side is at the back. So since this is a single component, which means this length that is given right there, that 86 is the same length for the front view because this is a single component. This is one thing. So now coming back at your cube construction, you already know that since this thing is in first angle orthographic projection, it means that your front view is gonna be there on this side, and then on this side it's gonna be your left view. And then the next step that you do is you draw a straight line from that point P, which is the lowest point, going up without measuring anything. So now this is the point where you start introducing dimensions. Since you know that your front view is gonna be in this side, now how long should you make this side be? You go back to your question. You look at the length of the front. The front is how long? The length of the front is the length from point P up to the end. And how long is that length? It's 86 millimeters. They've represented it for you at the top view. It's 86 millimeters. And then you come back to your drawing. You make this line 86 millimeters long. 86 millimeters long. And then the next thing you go over and look for the left view. How long is the left view? You go to your drawing, you come and check. Now, you cannot see the left view from the front because this is the front. The left side of the front is the side that is here from this position, but you cannot see how long it is because the dimensions that you can get from the front is the length of the front and the total height of the drawing. Those are the only dimensions that you can get from the front view. And then you shift to your top. You analyze your top view now. How long is your left view? Because this was the top, right? Because this is the top. And remember we said our left view is at this side, which is the left side of the top. And how long is it? When you look at it from here, there is 50, but then you don't know the distance from that 50 up to the end because it's chamfered there. You don't know the distance from where the 50 ends up to the end point because there is a chamfer there. But then when you look at the right hand side of your top view, there's 70 millimeters there, which gives us exactly what we need. Because if you complete this thing like that, there you cover your space, you make a whole complete square. How long is the distance from that corner to that corner? It's 70 millimeters. And this is the left side, which means the total left side is what? It's 70 millimeters. And then you come back to your drawing, you mark the left side as 70 millimeters. Now you go over and scan for what? For your total height. You go back to your question, you scan for the total height. Remember, you cannot see the height of the drawing from the top view because there is no height here. Here there's only the length and the side. So if you want the total height, you come to your front view. How tall is this thing? This thing is 100 millimeters tall because there is 50 and another 50. So the total height is 100 millimeters tall. So when you're constructing your cube, you only deal with the total length and the total height of the drawing. You do not deal with these halves like these 50s, because the cube that you are constructing is going to be guiding you up to the end of the drawing, because the whole structure, the whole component that you are required to recreate, it should stick inside that box. It should remain inside that cube. It should not overlap the cube. So the cube that you are creating is going to act as a border to your drawing. So whenever you are making a wrong dimensions, whenever you are marking a wrong dimension, the box is going to tell you that no, something doesn't make sense here, because now your lines are overlapping, they are going out of the box. So that's why you use your what? Your total dimensions, your maximum dimensions. You need the maximum dimensions for the sides, and you need the maximum height. Going back to your workplace now. We said the maximum height was what? Was 100 millimeters. You come and you mark your 100. So this is what you have now. You have the height, you have the length of the front, and you have the length of the left view. This is the only stage whereby you can complete your what? Your cube. You can complete your what? Your cube. So since the total height of the drawing is 100, every line that is going up when you are completing the cube, it should also be 100 millimeters. So the next thing that you do, because you are trying to come up with a 3D box here, is you create a line that is at an angle of 30 that is gonna go that direction, being parallel to that line right there, because now you are creating the base of the drawing. Remember, the front view was given to be 86 millimeters, so which means the line that you are producing there, it should be following is 86. It should be 86 millimeters also. And then the next thing, you complete your what? Your base, like that. And then you close the top side like that. We have the two faces of the cube. What's left now is to close the top side of the cube, which means we must have another 30-degree line that is going this direction and another 30-degree line that is going that direction. They are gonna meet where they are supposed to meet. Now notice how we only measured the front view, the length of the front, the length of the left view, and then the total height. But every other border that was projected there was projected from the three given dimensions. So that's how you do it. So since the left view is what is 70 millimeters long, and there is the right view, and then you go back to your drawing. This is the front. This side, there's gonna be a front view. This side is gonna be the left view because it's the left side of the front, which means the right view is gonna be where? It's gonna be on the opposite side. It's not gonna be seen because it's gonna be over there behind the box. The top is gonna be visible from there. Notice how we only measured that line right there. That's the only line that we've measured 86 millimeters long. But if you can take your ruler and measure the opposite top line, it's gonna give you 86 millimeters also, because everything was done by projecting. So every construction that is following, that is going at the direction of that line right there, is gonna be 86 millimeters long, because they were all constructed using that line. All the construction line that is following this one is going to be 70 millimeters long, because they were all constructed from this 70 millimeter dimension since we were creating the cube. And to prove that, we can go and measure that side over there. It's giving us 70 millimeters. You can go down and measure the one at the back. It's also 70 millimeters. So all the sides are corresponding to each other. They are parallel and they are equal to each other. The sides, we have the left side and the right side behind the cube. And those sides, they are both equal. And then we have the front side over here and the back side of the drawing. They are both equal. And then the top and the surface, they are also equal. And now the next thing you do when you are done with your cube, you start by transferring each and every dimension from your question to your cube that you've created right here. So you start with your front. It's up to you. You can start with the top or you can start with your front. So let's start with the front. We have this 25 that is going upwards right there, the 25 millimeter of the drawing, which is the thickness of that L shape right there. The thickness of it is 25 millimeters. And then you come back to your cube, you mark your 25 millimeters from the lowest point of the P. At this area, this is the lowest point. At this side, that is the lowest point. So which means if you were to mark your 25 millimeters at this line right here, you mark it from that point upwards. Here, you mark it from the center point upwards. Right there, you mark it from that corner upwards. So you mark your 25 right there, 25 millimeters. Now you go back to your question. You see there's a 25 millimeters that's going up, and then it's an L shape right there. But for now, you neglect the L shape, you neglect everything. For now, you're just marking the dimensions and you're creating construction lines only. So after marking your 25 millimeters, You create a construction line from there that goes up to the opposite corner right there. And then from that corner, it goes to the opposite corner right there. It touches all the four corners of your box. Since you've marked 25 here, you only mark it once. And then you take your what? Your 30-degree ruler. You transfer the point up to that corner. You transfer it to the next corner. You transfer it to the next corner. And then it comes back where it started. For each and every dimension that you mark, if you mark the dimensions along these borders right there, those corners right there, which means the dimension should rotate on all the corners to simplify everything for you. They should rotate on all the corners. If you mark them either at that line right there, or this line, or that corner, which means they should touch all the corners like that. Every dimension rotates. So you transfer the 25 millimeters that you marked here, you transfer it to all the corners, to all the other corners. It rotates until it comes back where it started. Now you go back to your question to get another dimension. We started from the point P upwards. We started from the bottom, we are going upside. So the next dimension, we have the 50 right there, which is the center point of the height, of the total height. We have 50, 50. So we're going to go ahead and mark that 50. So notice how the 50 is not from 25 to the upside, but it's straight from the bottom to the upside. 50 millimeters. You can mark your 50 millimeters anywhere. You can mark it at this line over here. You can mark it right there. It doesn't matter because the 50 is going to rotate also. So now you take your ruler, you mark 50 right there. And then the next thing you do, your 50 rotate. 50 and right back to where it started. So now it's like you are building layers. It's like you are building layers of the drawing before you put the actual drawing in there. And then the next thing, you go back to your question, you analyze, is there still any other dimension that is going outside? No, we don't have a dimension that is going outside anymore. So which means we are done with going up. Now with that, we have that 10 and the 15 at the top right there. And that 10 and the 15 at the top side right there, it's marked from the right hand side of the front. You start by 10, you go in by 10 millimeters, and then you go in again by what? By 15 millimeters. This space right here, it's 15, and then this step right there is 10 millimeters. So you mark it from the right hand side of what? Of your front, going to the left. So you head back to your cube right there. This is the front. This line right there is that point right there. You pull up your ruler, you go inside by 10 millimeters, and then you go inside by 15, and then the 15 start, you mark the 15 from your 10 millimeter. You don't mark your 15 from what? From scratch, because that is what the question is saying. The question says you go inside by 10, and then from the 10 you measure the 15. You follow the dimension, you follow what they are saying. So now we've already marked our 10, so the next thing is we mark our what? Our 15. Now, the next thing you do the same thing that you did for these previous points there. It should also rotate. So the dimensions that were marked at the vertical points right there, they were rotating at this direction. They were touching all the verticals. But now we're no longer marking the verticals. We marked at what? At this angled line here. So which means every line that is parallel to this line right here where you make the dimension, it should be marked at what? It should be marked with the same dimensions, which means the 10 millimeter should rotate, and then it goes back where it started. Every single dimension that you insert there, it rotates. And then the next step, you rotate the 15 because you are done rotating the 10. Now you rotate the 15. It touches there. It goes all the way to the opposite side of the base. It touches there. It goes up. It touches there, and then it goes back to where it all started. Now you go back to your question. to see if there's anything left. Now we're done with transferring the dimensions from the front view. Now let's go over and check our top if there's something missing. So you notice our top, we have that 15 there, we have that 50, we have that 20. Let's start with the 50 because it's on the left outer part of the drawing. It's not inside, it's not in the inner part, just the 15 and the 41. We're gonna deal with the 15 and the 41 at last. For now, we are dealing with the outer dimensions. We have the 50 and we have the 20. The 20 is at the front side of the drawing. That 20 represents that small square from point P up to that point right there. The distance from the corner to that point right there, it's 20 millimeters. It's the same thing. These things are communicating. These two views, they are communicating. They are telling you something. The front view tells you that there is a square shape, there is a square or a rectangular shape that you should see when you're standing at the front. That's what the front view is showing you. Whereby the top is showing you that that very same rectangular view that you see when you're standing from the front, it's also at an angle. It's also chamfered. So looking at your question right here, this is the left side. The 50 is at the left side and it's at that corner to this direction. You go back to your constructions. So your 50 starts at that corner to that direction because this is the front side. This is where by you see that rectangular shape from your front side. So the 50 is from that corner towards that direction. So you take your ruler, you mark the 50 right there. So if our 50 is here, it should also end where it started, which means it should go up to that line and then go up to that line, go out to the base and then comes back to where it started. Your 50 goes up right there, and then from there it goes straight down. It touches that end and then it comes back exactly where it started. And then you come back and take the last outer dimension, which is 20 millimeters from the front side. You take your ruler, you mark 20 from the lowest point. You have 20 millimeters there. And then the next thing, you transfer the dimension. It goes up, it touches the last border, it goes straight down, it touches the other, and it goes back right where it started. Now, everything that we've done so far, you've done it using what? Faint lines and faint lines only. You haven't outlined anything yet. So this is the point where you can start outlining if you want, or you can add the last two remaining dimensions before outlining. It's up to you. Because if you think now there's too many lines, you're gonna get confused, you can start outlining from this point. But if you think you can handle it, you're not gonna get mixed up within the lines, you can put the remaining two dimensions. You go back to your question and confirm which lines you can outline, starting with the front side. Right there at the back, you have that huge step that is 50 millimeters. You go back to your drawing and you mark that 50 millimeters what was from this point to that point right there. And then it goes in by 10, and then it goes up to the end, and then it goes in by 15. Now you're just doing, now you're just outlining the whole drawing. It's in there, it's within the cube. So now we are just outlining what you can see, because now you know you have this. Then the next thing you know that you have that closing there. Now you are sure that it's gonna go down, but it's gonna go down by how much? Where is it gonna end? You go back to your question, you confirm. From the 15, it goes down all the way to the 25, to the 20 feet level. So now you go back, you search for 20 feet level, and then your 20 feet level is that one, the one that you marked there. That was your 20 feet level, which means your line goes down to the 20 feet level straight. And then from the 20 feet, it goes straight up to the end. But now, remember that we have that chamfered shape right there at this point. That's why there's this line right there. So let's go over and put that straight line right there, which is the distance from point P 20 millimeters in. And then you go back, there is our point P right there, there is our 20 millimeters in, and then we have that distance right there that is going up to the 25. And then from that point, that's where it meets with the previous outlines. And then obviously it closes at the base like that. So now you were able to come up with the shape. At the front side, you were able to come up with that shape right there, which is this shape. You're able to come up with this part. You're already done with this part. Now we are here at this point. And at this point, going to the end, we have that chamfered side right there. So you go back to your drawing. The chamfer side from the top is is that point, is the joining of that point and that point right there, because this is where your 50 millimeters end, and where your 50 millimeters end is where the corner starts. So you go back to your drawing, you see where your 50 ended. So that slanted corner will start there and then it's gonna end at the 20. So there is our 50. Our 50 ended there. And then our 20 ended there from that side. So you join them with a straight line. Exactly like that. Same thing applies at the top. Right there. And then it goes down like that. And then moving on, already you know that it's gonna be closed at that area over there. Now you complete the base right there. And then now the next step, I think now everyone can get the picture. You can already see that this thing is gonna go there and then it's gonna go up and meet. Yes, it's gonna go like that, but remember, there is this part, there is this inner part right there that we have not yet transferred the dimensions for. So let's go back to the question and get the dimensions so that we can quickly outline everything else out. So now we have the 15 right there. The 15, if you pay attention, it's in line with the 20 millimeters there. So which means our 20, if you can transfer our 20 to that side, you're going to be able to mark the 15 at the same level right there. And then from the back side, you're going to shift from that 20 millimeters, you're going to move to the right hand side with 41 millimeters. So let's go ahead and do just that. Let's start with the 15 that is at the same level as that point right there, that 20 millimeter corner right there. So where is your 20? Your 20 is right there. And remember that you've already transferred your 20 to the other side. So there's no need for you to come this side and remark the 20. So the only thing that's left to do, you join that distance right there. So after joining, now you're gonna have to mark the 15, which is the thickness of what? Of that web right there. It's 15 millimeters thick. So then you go back to your drawing, you mark 15. From that side, you go inside by what? By 15. Now, after marking the 15 and this distance right here, we've already marked the 15. The 41, there's no need for you to go and measure the 41 because the 41 is left on its own right there. Because you've already came up with this whole area right there. You've already had this line. You've already had that line and then you have this line now, which means the distance automatically, the one that is left in the middle, it's 41 millimeters. That's the advantage of transferring the points because everything comes out on its own without even realizing it. So now we've already have our 41, we've already had our 15. The 15 is the thickness of the web, but how high is the web going? So if you want to get the height of the web, remember you cannot get the height at the top view. So this is the top. So now we shift from the top to the front because the front can show us how high is the thing. Now the web is the triangular shape, is that triangular shaped blade right there. We call it a web. So you can see that the web starts exactly from the top of the base straight up to the end of the component at that 15. And already in your drawing you've already outlined this part. right there. This part is already outlined. So now the only thing that you do, you just join this point and that point. You've already hit that point. So now the only thing that you do, you join the points right there. And then you have your 15 right there. You come to the top side, you mark another 15 right there so that you can be sure that the line you're going to draw is going to be parallel to that line. And then after marking the points, you join the second line. And now you're done with the thickness of the web. And then you go back to your question. When you look at the top where the web ends, the base continues right there to meet the left side at that corner. So you go back to your drawing, you outline that part where the web ends, the base continues all the way to the corner, and then you've outlined that part. Now you're almost done with the drawing. The only thing that is left now for your drawing to make sense is to complete that area right there. Now, since this is the 3D part and everything is welded in together, now the next thing that you do, you take this point, you throw it to that direction without measuring anything, and then you come back to this point right there, you throw it to that direction, and I guarantee you those 2 points will meet at that vertical line right there, because everything was done correctly and accurately. Those 2 points, they should meet exactly at that line right there. So now let's see if everything was done accurately. You draw that line to that point, and then from that point it goes straight to the end. And then as for the last part, this is where you close your web part. Now everything is done. The only thing that you do is you analyze your drawing for what? For the missing parts that are supposed to be outlined, but they are not. This side is fine, the top side is fine, this area is fine, and then there's this part over there, that small triangle, that small surface that is heading at the back side right there. You outline it until that corner over there, right there, because you cannot outline it all the way up to the back because you cannot see the back side, but you can see the what? Just the corner right there. And now when you've outlined everything in your drawing, you are sure that everything was done correctly. And at the end, you come up with the final product, which is something that looks like this. That is exactly like this. This is the component that you were required to construct. So now, notice how everything is packed inside the cube. This is our first cube that you started with. That is the cube right there. So you notice how every dimension and everything, the whole component itself is packed inside the cube. So the cube was our guideline. There's nothing that overlaps from the cube. There's no line that goes out of the cube. Nothing goes. That's why each and every dimension should rotate within the cube, because the cube was created using what? The dimensions from the given views, dimensions from the question. That's why there's no way your component can overlap the cube. So the cube acts as a guideline, as the border. So everything stays within the cube right there. Oh man, this is beautiful. Alright then, ladies and gentlemen, we are done for this session. Now you go over and practice this thing over and over again until you get the hang of it. TT out.